My name is Dr. Esther Trufan, and in this video, we're going to explore the extraction of calcium from chalk. Chalk is a good source of calcium because it's mostly made up of calcium carbonate. Now, to start the extraction of calcium, the first step is to remove the calcium from its original source and convert it into a soluble form. We accomplish that by reacting our calcium carbonate chalk with hydrochloric acid. The result of this reaction will be calcium chloride and carbonic acid, which is a very unstable acid that easily decomposes into carbon dioxide, which will be eliminated as bubbles from the solution, and water, which is a liquid that will add to the volume of our solution. It is important that for this reaction, the excess reactant be hydrochloric acid to ensure that all the calcium is fully converted from calcium carbonate to calcium chloride. If we don't add hydrochloric acid in excess amount, it is possible for some calcium to remain in the form of calcium carbonate. However, I want to remind you that when you performed the reaction of the chalk with the hydrochloric acid, there was always some turbidity to your solution, and that wasn't the calcium chloride or leftover calcium carbonate, but rather additives that were included in the chalk to make its color a brighter white. So if you see some turbidity and you added an excess amount of hydrochloric acid, you still extracted all the calcium. You just need to do the filtration to remove these additives before you can move on to the next step. The species in the solution will be the calcium ion and the chloride ions, which come from the dissociation of calcium chloride. There also will be some chloride ions that come from the ionization of hydrochloric acid, and the hydrogen ion that comes from the ionization of hydrochloric acid will often bind itself to a water molecule, creating this H3O plus species that is called oxonium. In older textbooks, you may find it referenced as hydronium ion. Once you have your calcium in a soluble form and you removed all the additives using a prior filtration step, you are ready to precipitate your calcium chloride. And so you need to add something that will cause the calcium to precipitate. And in this case, we used sodium carbonate. The carbonate from sodium carbonate will react with calcium to produce calcium carbonate. In very old textbooks, you may find precipitates indicated with an arrow pointing down, showing that it is crashing out of the solution. Most of the time it will build up on the bottom of the beaker. You also have some leftover hydrochloric acid, since the hydrochloric acid was your excess reactant in the previous step. That also has to be neutralized, because otherwise you will have calcium carbonate and hydrochloric acid in the same solution, and those two will react again. Important here is that the excess reactant has to be the sodium carbonate. This is soluble in water. So when the reaction is complete, the only thing that will precipitate or that will produce an insoluble solid is the calcium carbonate, and every other species will be left in solution. So the sodium chloride will dissociate into sodium and chloride ions. The leftover sodium carbonate will dissociate into sodium and carbonate ions. All of these can be filtered away and rinsed with a substantial amount of water, so that on your filter paper, once you completed your filtration, you only have calcium carbonate. Then you can dry it and you can quantify the amount of calcium that you extracted from your chalk.